Hello dear students, welcome back. Previously we had discussed about fundamental theorem of arithmetic. So today in this session we are going to cover prime factorization and decimal expansion. Okay, so let's start with prime factorization. Prime factorization is mainly consists of two words, as you can see. One is prime and another one is factorization. So about the primes we had discussed briefly in fundamental theorem of arithmetic. There we had learned that primes are the numbers which has exactly two factors, or the numbers which are exactly divisible by 1 and the number itself. So some examples of primes are 3, 5, 2, 7, 11, 13, 17 and so on. Next move to the second word, that is factorization. Factorization means when a number is expressed as the product of its factors, then it is called factorization. For example, say 12. 12 can be written as 2 times 6. It can also be written as 3 times 4. It can also be written as 3 times 2, 6 times 2, 12. It can also be written as 12 times 1. So a number can be written in many ways by multiplying the factors of that given number. So in all these four ways 12 can be factorized, or we can say these are the factorization of 12. Out of these four factorizations, one of these is prime factorization. Which one it is? The factorization which contains only the prime numbers, that is this one, 3 times 2 times. Here each of the factors that we wrote, 3, 2, 2, each of them are primes. But in other cases you can see here 2 is prime but 6 is a composite one. Here 3 is prime but 4 is a composite one. And in the last case 12 is a composite one and 1 is neither prime nor composite. So a number can be written by multiplying its prime factors, and their factorization is called prime factorization. Okay, and in fundamental theorem of arithmetic we had learned that a composite number can be written by multiplying its prime factors in a unique way. Means no other prime factorization can represent 12, that is only 3 times 2 times 2 can represent 12. Yes, the order may be changed, 2 times 3 times 2 can also be written, or 2 times 2 times 3 can also be written, and this is called prime factorization of 12. So now I hope you would have understood what prime factorization is. Prime factorization is expressing a number, let me write it. Prime factorization is expressing a number as the product of its prime factors. Okay, so when a given number is expressed by multiplying its prime factors, then those factorization or that expression is called prime factorization of that given number. And one of the most important use of prime factorization is finding out HCF and LCM of two or more positive integers, and we are going to discuss about that in next session. Today we will see how prime factorization can be used to find out the decimal expansion of a rational number. Means how to identify whether a rational number has terminating or non-terminating decimal expansion, that we will see later in this video. One of the most important use of prime factorization is finding out HCF and LCM of two or more positive integers, and we will see how to use prime factorization to find out HCF and LCM in the next session. Today we shall discuss how prime factorization can be used to find out decimal expansion of rational number. Means how to decide or how to identify which rational number has terminating decimal expansion and which has non-terminating repeating decimal expansion. Before that, let's solve some questions which comes most often in board exams directly from this concept of prime factorization. Let's solve the first one. The first one will be like this, very simple. Express 154 as the product of primes. So the question is, we have to express 154 as the product of its prime factors. So simply we need to factorize 154. How will we do this? Simply we need to factorize 154 by only its prime factors. No composite factors will be used here. So first see, here 154 is an even number as 4 is in its unit place, so it can be exactly divisible by 2. So what we need to do? We need to divide 154 by 2. 2 7 ja 14, 1 is remainder here, then 4 will be stepped down. So again 2 7 ja 14, and here the quotient is 77. And we don't need to do this division again and again. We need to do all this in our mind and we need to write it directly here. We will write here like this, 2 7 ja 14 and 1 will be left here, and 1 4 14, again 2 7 ja 14. Next what we need to do? Next we can easily say that 77 is exactly divisible by the prime 7. So let's divide it by 7, so it will become 7 1 ja 7, 7 1 ja 7. Now we got 11, and which is a prime number, so we can't divide 11 by any other number. So next we can write this 154 as 2 times 7 times 11. We just need to multiply these primes that we got while factorizing 154. This is the answer, that is 154 now expressed as the product of its prime factors. Okay, so this one was a very simple question which comes most often in the CBSE board exam. Let's see another type of questions related to this prime factorization. So the next type of question is something like this: find the missing term. So there is a factor tree as you can see here, and there are 3 question marks here, and we need to find out which numbers can be replaced in these question marks. So let's solve it. So we'll go from this side, as 36 already given, we can write it 36 and here it is 2. So let's divide it by 2, we'll get 2 1 ja 2, 1 6 16, 2 8 ja 16. So here we got the quotient 18. So we can replace this question mark now by 18. Next 18 is again factorized, and here as we can see here it is 6. So let's divide it by 6. So 6 3 is 18. So this question mark now can be replaced by 3. Next here again 6 is factorized and one of the factor is 2. So let's divide it 6 by 2, we will get 2 3 is 6. So this question mark now can be replaced by again 3. So these type of questions are very easy, and we were solving this type of questions in class 7 also. So we need not to give much time to this. Let's move to our next concept, that is decimal expansion. So everyone know about the decimal numbers. So what is decimal expansion? Decimal expansion means when we just write the rational numbers in the form of decimal numbers, those are called decimal expansion. Okay, for example, if we have given a rational number, we have been given a rational number such as 31 by 10. Okay, 31 by 10. It can be written as 3.1. It is very easy because 10 was in the denominator. When we get 10 or any power of 10 in the denominator, it becomes very easy for us to express that fraction or the rational number into decimal number. And how do we do this? If we have 10 to the nth power in the denominator, then we just leave n places from the right sides of the numerator, then we place the decimal value. Means here if you would be given 314 or 3148 divided by 10 to the second power or 10 squared, how do we do this? We just write 3148, then it is 10 to the second power or 10 squared, so we will leave two places here, 1 2, 8 and 4, we will leave 8 and 4, then we will place the decimal point here, so it becomes 31.48. So it is very easy to express the rational numbers to the decimal when 10 or 10 to the any power is in the denominator. If there is no 10 in the denominator, say it is 31 upon 5. So here how to express this rational number in decimal number? For this we need to divide 31 by 5. So we will get 5 6 the 30. 1 is in the denominator, let's place a decimal value here. Then for the decimal point we will get a 0. Now 5 2 ja 10, 0. So it becomes 6.2. Okay, let's take another example, say 20 upon 6. How will you do this? We will divide 20 by 6. We will get 6 3 ja 18, 2 was remainder. Then we will put a decimal point here. For that we will get 20 again. Then 6 3 ja 18. We will get again 2 as remainder, and this process will be repeated and the answer will be 3.33 and so on, or we can write it simply by 3 point bar on 3. Okay, so when we express any rational number to decimal number, then we get either a terminating decimal number or a non-terminating repeating decimal number, as you can see here. And every time if 10 or 10 to the any power is not in the denominator, we need to divide the numerator by the denominator to find out whether the rational number has terminating or non-terminating decimal expansion. But now we need not to follow that long method of division to decide or to identify whether the rational number has terminating or non-terminating decimal expansion. Here prime factorization can be very much useful. Let's see how prime factorization can be used to identify which rational number has terminating and which rational number has terminating and which rational number has non-terminating repeating decimal expansion. So let's see by taking an example. So the question here is, find out which of the following rational number has terminating and which has non-terminating repeating decimal expansion without actually dividing. As I had mentioned earlier, that you have to identify these rational numbers decimal expansion without actually dividing the numerator by the denominator. So how will we solve this? After solving these three, I am sure you will have a mastery on this type of questions. So let's solve the first one. What's the first step while solving this type of question? The first step is always you have to find the prime factorization of the denominator. Okay, so let's do it. Here the denominator is 1250. So let's find the prime factorization of 1250. Here a 0 is at the unit place, it can exactly divisible by 2. So let's try by taking 2 as the factor. So 2 6 ja 12, 2 2 ja 4, here 1 will be remainder, so 10 will be left. So 2 5 ja 10. Next, here as 5 is at the unit place, it can exactly divisible by 5. So now 5 1 ja 5, 5 2 ja 10, 5 5 ja 25. Next 125, it can also be exactly divisible by 5. So 5 2 ja 10, 5 5 ja 25, we got 25. So again 25 can be divided exactly by 5, 5 5 ja 25. Now we got 5 as the last number, which is a prime number. It can be divided by any other number exactly. So now we can replace this 1250 as 2 multiplied by 5 to the 4th power. As 5 is multiplied 4 times, we can write 2 times 5 to the 4th power. Okay, now the first step is complete. Next we will see what prime factors comes in the factorization of denominator. If we are getting only 2, or we are getting only 5, or we are getting only 2 and 5, means there is no other prime number in the prime factorization of the denominator, then this rational number has terminating decimal expansion. Okay, again I am repeating, if the prime factorization of the denominator contains only 2 or only 5 or both 2 and 5, not any other prime numbers, then this rational number has terminating decimal expansion. Okay, very simple. We can write it has terminating decimal expansion. There may be another type of question come in your exam, that what can you say about the denominator of a rational number which has terminating decimal expansion? Okay, what can you say about the prime factorization of the denominator or the denominator of a rational number which has terminating decimal expansion? The answer will be, the prime factorization of the denominator must have contained only 2 or only 5 or both 2 and 5. There will be no any other prime numbers in the prime factorization of the denominator. That will be the answer. Okay, so now let's move to the second one, that is 13 by 375. So as I told, at the first step we have to factorize 375. So let's do it. 375 becomes, now 3 is a prime number, so we can't continue this process now. Now we can write 13 by 375 as 13 by, in place of 375 we can write 5, 5, 5, 3 5s are there, so 5 cubed multiplied by 3. So here what happens, we got 5, as we just learned that if the prime factorization contains only 5, then it will have terminating decimal expansion. But here along with 5 there is also another prime factor, that is 3. So this rational number 13 by 375 will have a non-terminating repeating decimal expansion. Understood? If it contains only 2 or only 5, then it will have terminating decimal expansion, or 2 and 5 both. But here along with 5 there is a 3, so it will have non-terminating repeating decimal expansion. So let's write it. Very simply we can write it has non-terminating repeating decimal expansion. You will have to write it completely. Here I have no space, so I am writing just in shortcut n.t.r, that is non-terminating repeating decimal expansion. So let's move to the last one, that is 27 by 375. We had just recently prime factorized the 375, so we will not again do that. We can clearly write 27 by, in place of 375 we had got 5 cubed times 3. Okay, so now what happens, here also we have 3 in the denominator along with 5. So according to the concept that we learned, if it contains any prime factor other than 2 or 5, then it has non-terminating repeating decimal expansion. But here what happens, see, we have 3 in the denominator no doubt, but 3 can easily be cancelled with the numerator 27. What will we get? 3 1s are 3, 3 9s are 27. So now this 27 by 375 becomes 9 divided by 5 cubed. Okay, now here 5 cubed is only at the denominator, there is no any other prime factors. So we can write this has terminating decimal expansion. Okay, so very simple. Let's now just update our steps. That in the first step you need to find out the prime factorization of the denominator. Then you have to check whether the denominator's prime factorization contains only 2, if only 2, terminating, if only 5, terminating. But if it contains any prime numbers other than 2 or 5, then you have to check whether that extra prime factor is cancelling out the denominator. If it is being cancelled by the numerator and we are getting only 2 or 5 again in the denominator, then we can write it as terminating. We can see this second and third example to be very clear, that here there was 5 cubed and 3 can be cancelled by 13. So it has non-terminating repeating decimal expansion. Here we have got 27 by 5 cubed and 3, that is the same as the previous one in the denominator, but here 3 can be cancelled out by 27 as 3 9 ja 27. So now we have 5 cubed left only in the denominator. So it has terminating decimal expansion. We can write it has terminating decimal expansion. Okay, so now I hope this type of questions can be solved by you very easily. Now let's move to another type of question related to decimal expansion of rational numbers. The question is given, find the decimal expansion of 27 by 1250. Here it is not given to check whether it has terminating non-terminating, it is asked to find out the decimal expansion. Sometimes these two types of questions are combined together and the questions may come like this: find out which of the following rational number has terminating decimal expansion, and if it has terminating decimal expansion, then find out the decimal expansion. So I am just only doing the second part, that is find out the decimal expansion. So how to solve this? Here also we will do the first step as we are doing here, that we have to factorize 1250. I have factorized 1250 here, so we don't need to factorize it again. But in the question, if it is not mandatory that always it will be 1250, so if there would be any other number, you have to factorize that. So I am not just to save time writing it directly. So here it is the question given 27 by 1250. It can be written now as 27 by what was there? Yes, 2 ones and 5 4 times, or 5 to the 4th power. So the first step is same as the previous question. Next, what we need to do? We know that as I had told earlier how to find how to express rational numbers into decimal expansion, I had taken an example like 31 by 10, and there we had learned if we have only 10 or 10 to the any power, it is very easy for us to convert that to decimal number. So here we will try to convert this to 10 to the any power. Okay, so how will you do this? See, here there is 1 2 and 4 5s multiplied together. So here 5 into 2, it becomes 10, but here there are 3 5s, and to make them 10 we need 3 more 2s. So what will you do? We will multiply 1 2 3 2s here. If you will multiply 3 2s here, then this 5 into 2 will give you 10, this 5 into 2 give you another 10, and this last 5 into 2 will give another 10. So to get 10 to the any power, we need to multiply 3 2s in the denominator. So if we multiply, what will we get? We will get 2 into 5 to the 4th into 2 cubed, and as we multiply anything in the denominator, then the value of the fraction of the rational number will be changed, and to make it equivalent, what will we need to do? We will need to multiply that same 2 cubed in the numerator just to keep this equivalent. Okay, in the next step, what will we write? We will write it becomes now 27 multiplied by 2 cube is 8 and 2 to the 4th power into 5 to the 4th power. This is 2 and 2 cube multiplied together to give you 2 to the 4th power, and 5 to the 4th power is already there in the denominator. So now this becomes 27 into 8. Let's multiply it. 27 multiplied by 8, 8 7 is 56, 8 2 is 16, 5, 21, 216. Okay, the numerator becomes 216 and the denominator 2 to the 4th and 5 to the 4th power multiplied together. So each 2 5 pair will give you 10. So now you will get it 10 to the 4th power, or 4 tens will be multiplied together to give you 2 4th times 5 4th power. Now as we had learnt it very earlier that if you have 10 to the 4th power in the denominator, then you will have to leave 4 places from the right sides of the numerator, then you will put the decimal point. So what will you do? We will just write the numerator first, then 10 to the 4th power means we will leave 1 place, that is 6, 2 place 1, 3 place 2, and there is no 4th place, so for that we will give a 0. So 4 places are left now. Next we will put the decimal point. Okay, so it becomes 0.0216, or we can write another 0 in the left side. So now 27 by 1250 becomes 0.0216. Okay, it is very simple. What you need to do, every time at first you have to factorize the denominator first, then you have to check if 2 and 5 has same exponent. If it has same exponent, there you don't need to do the second step. If the exponent of 2 and 5 are not same, you have to make them same by multiplying either 2 or 5, whatever needed in the question. Here 2 was once and 5 was 4 times there, so I had to multiply 2 3 times to make the coefficient of make the exponent of 2 and 5 equal. Here the exponent of 2 becomes 4 and exponent of 5 becomes 4. So as per the need of the question, you have to multiply either 2 or 5. Then you get 2 to the 4th power, 5 to the 4th power here, so it becomes 10 to the 4th power. And if you are getting 10 to the nth power in the denominator, then leave n digits from the right sides of the numerator, then put the decimal point. Here 10 to the 4th power was there, so I had to leave 4 digits from the right side, but there was exactly 3 digits in the numerator, so I had to add another 0 to make this 4 digit number. Then I place the decimal point here, then again before the decimal point I wrote 0, so the answer becomes now 0.0216. Okay, so these two types of questions may come separately or may come combinedly, as I told you earlier. Okay, so next we will do another very simple question related to this decimal expansion and we will complete this session. So the last type of question from decimal expansion is, after how many decimal places will the decimal expansion of the following terminate? Okay, there are two questions given here and we need to say after how many. Yes, obviously it is given terminate means the decimal expansion of these two questions will be terminating decimal expansion, but we need to say here after how many decimal places will it terminate. See, in the first type of question it was given you have to check which has terminating, which has non-terminating repeating. In the second type of question it says you to find out the decimal expansion. No need to check, you have to directly say the answer, what is the decimal expansion of the rational number. In the third type of question you need to only say after how many decimal places it will terminate. You don't need to find out the decimal expansion, you have to just say after how many decimal places will the rational number will terminate. So in the first question the denominator is already factorized, so it becomes very easy for us. So you can see here 2 to the 7th power and 5 to the 4th power. The exponents are not same. So what we need to do, here we had learnt if the exponents are not same, you have to multiply either 2 or 5 as per the need to make the exponents equal. So here as 5 is 4 times here and 2 is 7 times, so we need to multiply 5 cubed here and also in the numerator to make it equivalent. So now it will become 119 into 5 cubed divided by 2 to the 7th power and 5 to the 7th power. You don't need to do all this, I am just doing this. After that I will say how can you answer this only by looking at the question, no need to do all this process. Okay, now next you will get a number in the numerator and in the denominator you will get 10 to the 7th power. Okay, so here I am just circling this as I had multiplied extra. So now as it is 10 to the 7th power, okay, 10 to the 7th power means we have to leave 7 digits from the right sides of the numerator, then we will have to put the decimal point, means the given number will terminate after 7 decimal places. So it is very simple. What we need to do, we don't need to do all this process, we just have to check in the question which exponent is greater. Here 2 has 7 as its exponent and 5 has 4 as its exponent, and 7 is greater than 4. Yes or no? 7 is greater than 4. So this question or so this rational number will terminate after 7 decimal places. Simple. You have to check in the prime factorization of the denominator which of the following, it may be 2, it may be 5, has greater exponent, and that greater exponent is the answer of this type of question. Okay, if it would have 2 to the 7 and 5 to the 9th power, then the answer would be 9, because you have to multiply 2 2's to make it 10 to the 9th power, and if 10 to the 9th power is in the denominator, then the rational number will terminate after 9 places. Okay, so just prime factorize the denominator. If already it is prime factorized, just look which exponent is greater. The greater exponent is the answer of this type of question. So let's solve the second one. In the second one, it's not factorized, so you have to do the first step as you are doing in the previous two questions, that is you have to factorize. Zero can be written as 2 multiplied by 5. How many times are there? 1, 2, 3, 4, 5 times are there. 2 into 5 to the 5th power. So here 2 has exponent 1 and 5 has exponent 5, and 5 is greater than 1, so the answer is 5. If you do this process as we had done in the second one, you will get a decimal number in which after decimal point there will be 5 decimal places. So this is all. These 3 types of questions most oftenly come in board exam from this concept of using prime factorization to find out the decimal expansion of rational numbers. Hope you all understood these concepts and you can solve your textbook exercises and practice this well.